Hello, welcome to Math. So, integral 2 raised to the power x multiplied by ln2 dx. So, integral 2 raised to the power x multiplied by ln2 dx. Now, in my previous video, I differentiate 2 raised to the power x, and I had 2 raised to the power x multiplied by ln2, which is this one. So, in this video, I'm going to integrate 2 raised to the power x multiplied by ln2, which is the answer that I had to the differentiation question. Okay, so without wasting much time, let's get into the video. First, let's write our solution. Now let's repeat this. Integral 2 raised to the power x multiplied by ln2 dx. Now let's bring this constant outside here. Here we are going to rewrite 2 raised to the power x using natural log. We are going to rewrite 2 raised to the power x using natural log. Okay, so rewrite 2 raised to the power x using natural log. Now let's rewrite. E raised to the power ln2 to the power x dx. Now here we are going to do substitution. We are going to do substitution. We are going to let u be equal to ln 2 raised to the power x. We are going to let u be equal to ln 2 raised to the power x. So u is equal to ln 2 raised to the power x. Now from the laws of logarithm, this x here can be written at the back here. Okay, so let's write it there. U is equal to x ln 2. Here we are going to differentiate. Now to differentiate this, now when you differentiate u, you are going to get du. But to differentiate this, we have to use the product rule. Okay, so to use the product rule, first we maintain x and then we differentiate ln2. Now when you differentiate ln2, you're going to get 0. And 0 multiplied by x will give you 0. And then we add it to. Now the next one is we are going to maintain ln2 and then we differentiate x. Now when we differentiate x, we are going to get 1. 1 multiplied by ln2 will give us ln2. So 0 plus ln2 will give us ln2 dx. Okay, so when you differentiate this, you are going to get du is equal to ln2 dx. Okay, du is equal to ln2 dx. Now let's divide both sides by ln2. Divide this one by ln2, this one also by ln2. Now here, this will cancel out with this and it will be left with dx. So we are going to get dx equal to du over ln2. Dx equal to du over ln2. This one is the same thing as this one, so don't get confused. Okay, now let's put this one into the integrals and let's continue from there. ln2 integral e to the power u multiplied by 1 over ln2 du. Now this one too is a constant, so let's bring this one outside here. But mind you, when we bring it outside here to multiply this one, okay, so let's bring it. One over ln2 multiplied by ln2. Now this and this will cancel out, and to be left with integral e to the power u du. Okay, now when you integrate this, you are going to get e to the power u, e to the power u, but u is equal to ln2 raised to the power x, but u is equal to ln2 raised to the power x. So wherever we see u, we are going to put 2 raised to the power x there. Okay, so let's put this one here. Okay, now e raised to the power ln2 raised to the power x, this is going to give us 2 raised to the power x because the base of the ln is e and we are having another e here. So the base of this ln will cancel out with this e and it will be left with 2 raised to the power x. Okay, so this is going to give us 2 raised to the power x. Therefore, integral integral 2 raised to the power x multiplied by ln2 dx equals to 2 raised to the power x plus c, which means that the answer that we have to the differentiation question, which was this, is correct. Okay, all right, that's it. Please, if you like this video, give it a thumbs up, subscribe and comment. Thanks for watching.